Good morning students. In today's video we will solve exercise 1.2 question number 3rd. The question is prove that the greatest integer function f such that r to r given by fx is equals to greatest integer function x is neither 1 1 nor onto, where x denotes the greatest integer less than or equal to x. We have to check the given function is neither 1 1 or nor onto. For 1 1, so let we select any two elements x1 and x2 with a set of real numbers. It means we select the function x1 x2 from codomain. For classification, I will make two sets over here which contain the set of real number. So 0, minus 1, minus 1.1, minus 1.2, minus 1.3 and minus 2. And here 1, 1.2, 1.2, 1.3 and 2. And same the elements in set B. So real number containing negative integer, negative decimal, 0, positive integer and positive decimals. So what we have to prove? We have to prove given function is not 1 1. So we have to select any two element from codomain x1 and x2. Let x1 is equals to 1.1 and x2 is equals to 1.2. According to the question, fx1 is equals to greatest integer function x1. Now we put the value of x1, that is 1.1. So greatest integer function 1.1 gives you 1. And second, fx2 is equals to greatest integer function x2. So put the value of x2. So greatest integer function 1.2 is equals to 1 2. Now fx1 is equals to fx2, but just look at the value of x1 and x2, which is not equal to x1 does not equal to x2. So we can say that f is not 1 1. Now we check the onto. For onto we have to select any element, an element y which is belongs to set of real number and from codomain. We know that y is equals to fx is equals to greatest integer function x, and that I will select y from codomain. Y is equals to 1.2. Now put the value of y. So greatest integer function x is equals to y. Further, greatest integer function x is equals to 1.2. So there is a problem. The problem is what? We cannot get a decimal answer for greatest integer function. So it means it is not possible. Therefore, f is not onto. And every decimal number does not have their pre-image in domain. Now next, question number 4. The question is, show that the modulus function f belongs to r given by fx is equals to modulus x is neither 1 1 nor onto, and where modulus x is equals to x if x is greater than 0 and minus x if x is less than 0. In this case we have domain real number and codomain also real number. So what we have to prove? We have to given a modulus function, and we also know modulus function getting a always positive value. So let's start with the solution. First we check for 1 1. So let x1 and x2 be two elements from the set of real number codomain. Let x1 is equals to 1 and x2 is equals to minus 1. For classification, I will make two sets over here, set A and B, set of all real numbers. So 0, minus 1, minus 1.1, minus 1.2, minus 2, and 1, 1.1, 1.2 and 2. And similarly in set B. So fx1 is equals to modulus of x1. We put the value of x1. So modulus of 1, that is 1, And next, fx2 is equals to modulus of x2 and value of x2 minus 1. So modulus of minus 1, which gives us 1. Now we can see that fx1 is equals to fx2, but x1 does not equal to x2 because value of x1 1 and value of x1 minus 1. It means x1 does not equal to x2. So we can conclude that f is not 1 1. Now for onto, we have to select one element. Y belongs to set of real number, and from codomain y is equals to fx is equals to mod of x. Let me select y is equals to minus 1 from codomain, it means set of B. So modulus of x is equals to y. Now put the value of y. So modulus of x is equals to minus 1. It is not possible. It means for every negative value in codomain, there is no pre-imagine domain. If we are putting the positive value, we are getting positive, and if we are putting negative value, we are getting also positive. The negative real number are left, so there are no pre-image for negative integers. For every negative value in codomain, there is no pre-image in domain. Therefore, f is not on. Therefore, f is not onto function. Hence, it is proved that f is not 1 1 and f is not onto function. Thank you.